Bismillahirrahmanirrahim. The quote of the day is kindness is a wonderful way to let another way struggling soul know that there is still love in this world. May Allah grant love, empathy, and compassion in the heart of all mankind. Today we will discuss about the ventilation, and I am giving this presentation under the kind supervision of Professor Dr. Said Afzal. Today we will learn about the ventilation types, standard and requirements for ventilation, health risk and poor ventilation, indoor ventilation in the era of COVID-19, recent updates, and at the end are the MCQs. By the end of this presentation, the participants will be able to describe the different types of ventilation and use of ventilation systems in different working environment, homes, and schools. No ventilation, no ventilation is the term that is used when the air when ventilation into a building or room and distributes the air within the building or room. The reason for ventilation is to provide healthy air for preventing the pollutants or diseases or pollutants from it. Ventilation is uh, broadly defined as a method of controlling the environment with airflow. For indoor environments, providing some degree of ventilation, supply, and exhaust to building occupants is necessary. Issues of comfort, temperature, humidity, or movement can quickly arise in occupied indoor environments if there is lack of ventilation. As such, inadequate or improper ventilation is the cause of about half of the all indoor air quality problems in non-industrial workplaces. Now, building ventilation has three basic elements that are ventilation rate, airflow traction, air distribution, or airflow pattern. Now, ventilation rate is the amount of outer air into the space and the quality of outer air. Air flow direction is the overall air flow direction in a building, which should be from clean zones to dirty zones. And air distribution and air flow pattern is the external air that should be delivered to each part of the space in an efficient manner, and the airborne pollutants generated in each part of the space should also be removed in an efficient manner. From the viewpoint of comfortable living and working conditions, the good and efficient ventilation system should meet the following functional requirements that are rate of supply of fresh air movements, air changes, temperatures of air, humidity, and purity of air. There are three methods that may be used to ventilate a building that are natural, mechanical, and hybrid systems that are mixed mode ventilation system. Now, the natural ventilation are the natural forces that are winds or the thermal buoyancy force due to indoor and outer air density differences that drive the outdoor air through purpose-built building envelope openings. The purpose-built openings include windows, doors, solar chimneys, wind towers, and vertical ventilators. This natural ventilation of buildings depends on climate, building design, and human behavior. Mechanical fans drive the mechanical ventilation fans. Fans can either be installed directly in windows or walls, or installed in air ducts for supplying air into or exhausting air from a room. This is an example. The type of mechanical ventilation used depends on climate. For example, in warm and humid climate, and the other one is in cold climates. In warm and humid climates, infiltration may be needed to minimize or prevent it to reduce the interstitial condensation, which occurs when warm, moist air from inside a building penetrates a wall, roof, or floor and meets a cold surface. In these cases, a positive pressure mechanical ventilation system is often used. Conversely, in cold climates, exfiltration needs to be prevented to reduce interstitial condensation, and negative pressure ventilation is used. For a room with locally generated pollution, such as bathroom, toilet, or kitchen, the negative pressure system is often used. Now, the mixed mode or the hybrid ventilation system. This ventilation system relies on natural driving forces to provide the desired flow rate. It uses mechanical ventilation when natural ventilation flow rate is too low. When natural ventilation alone is not suitable, exhaust fans can be installed to increase ventilation rates in rooms, housing patients with airborne infection. However, this simple type of hybrid mixed mode ventilation needs to be used with care. The fans should be installed where the room air can be exhausted directly to the outdoor environment through either a wall or the roof. The size and number of exhaust fan depends on the targeted ventilation rate and must be measured and tested before use. Use of exhaust is by far the most effective method of home ventilation. No HVAC. It is heating, ventilation, and air conditioning. It is important in those places where humidity and temperature must be closely regulated while maintaining healthy and safe conditions inside building. To ensure thermal comfort, accessible indoor quality at reasonable installation, operation, and maintenance for. Relaxation determine the room air distribution, where it is delivered and removed from room spaces. Now the air conditioning. Air conditioning is the process of removing heat, bacterial content, controlling the humidity of air in an enclosed space to achieve a more comfortable interior environment by the use of powered air conditioners or a variety of other methods including passive cooling and ventilative cooling. Air conditioning is a member of air conditioner is a member of family of systems and techniques that provide heating, ventilation, and air conditioning. Assessing ventilation performance. Ventilation performance in buildings can be evaluated from the following four aspects corresponding to the three basic elements of ventilation discussed above. These are first one is does the system provide sufficient ventilation rate as required? Second one is the overall air protection in the building from clean to dirty zones. Area isolation rooms are areas of contamination such as a laboratory. Coefficient is the system in delivering the outdoor air to each location in the room. Coefficient is the system in removing the airborne pollution from each location in the room. Air movement caused by general ventilation can affect the comfortable working conditions. Your workers will be healthier and happier if they can alter the air environment, for example, by opening or shutting a window when required. At normal temperatures, an airflow velocity of between zero point 0.1 to 0.15 meters per second and up to 0.25 meters per second during the summer is recommended by CIBSE, that is a Chartered Institution of Building Services Engineers. One of the ventilation standards. To achieve a sense of freshness in a room and remove body odors, there should be adequate floor space. It should be the and the what should be the adequate floor space? It is the product of length and breadth of optimum floor space required per person, that is from 50 to 100 feet. Then the next one is cubic space of the area. Earlier prescriptions, fresh air supply of 3,000 cubic feet of air per person per hour beyond 12 feet, not considered current standard. 1,000 to 1,200 cubic feet per person per hour. Air change. The recommended number of air changes living room are 2 to 3 in an hour. Workrooms and assemblies for data 4 to 6 per hour. Now, the ventilation rate refers to the volume of air that is provided to a room over a period and is often stated in building guidance as recommended values. Some guidance recommends ventilation rates in terms of liters per second per person. A value of 10 liter per second per person is recommended in many guides as a suitable value for the most commercial buildings. Some documents state ventilation rates in terms of changes per hour, which is a measure of the airflow relative to the room size. The measure can be useful to understand how quickly the ventilation removes the contaminants from the air. A ventilation rate of 6 air charges per hour would mean that 6 times the volume of the room is provided every hour by the ventilation system. Now, the recommended fresh air supply rate of 8 liters per second per person should provide a clean and hygienic workplace in open and plain offices, shops, and even in the factories. Higher fresh air supply rates of up to 36 liters per second per person are recommended for a heavily contaminated building. For example, 70% of people smoking. Now, the condensation. It is a deposition of moisture in the room surfaces. The proper and sufficient ventilation results in the absence of condensation. It can be effectively controlled by the provision of suitable ventilation of the room. The carbon dioxide level. The quality of air inside a building depends on the concentrations of contaminants such as gases and particles, and how much the fresh air is brought into the building through its ventilation system to dilute and remove these pollutants. Carbon dioxide measurements are useful to help you in determining if a building has adequate ventilation and to verify that enough uh, OSA, that is obstructive sleep apnea, is coming in to show good in IAQ. Carbon dioxide known levels. uh, 35,000 to 50,000 parts per meter. It is a motor carbon dioxide in each exhale by an average year. Then is 5,000 parts per meter. That is the maximum allowable carbon dioxide level in an industrial workplace. Then is the 380 parts per meter. That is the typical carbon dioxide level in outside air. Then is the 650 parts per meter. That is indoor carbon dioxide level should not exceed the local outside air concentration by more than 650 parts per meter. No, these are the list of tools that can be universally applied across indoor environments. The specific combination of tools chosen for use at any point in time can change. It will be up to the building owner or operator and to identify which tools are appropriate for each building throughout the year. No, for proper increase the introduction of outdoor air, open windows and doors when the weather conditions allow. To increase the outdoor airflow, do not open windows and doors if doing so poses a safety or health risk to occupants. Use can to increase the effectiveness of open windows, ensure ventilation system properly and provide acceptable indoor air quality for the current occupancy level of for each space. Rebalance or adjust uh, heating, ventilation, and air conditioning system to increase the total airflow to occupied space when possible. Turn off any demand control ventilation controls that can reduce air supply based on occupancy or temperature during occupied hours. Ensure restroom exhaust fans are functional and operating at full capacity when the building is occupied. Inspect and maintain exhaust ventilation system in areas such as kitchens, cooking areas, etc. Operate these systems anytime these spaces are occupied. Operating them even when the specific space is not occupied will increase the overall ventilation within the occupied building. Use portable high efficiency particulate air fan or filtration system to enhance air cleaning. Generate clean to less clean air movement by evaluating and repositioning as necessary. The supply lowers exhaust grills or damper setting. Use ultraviolet germicidal irradiation as a supplemental treatment to inactivate SARS virus when options for increasing room ventilation and filtration are limited. In non-residential setting, run the heating, ventilation, and conditioning system at maximum outside or airflow for the hours before and after the building is occupied. In addition to buildings, vehicles, including public transport such as buses, subways, trains, school buses, carpools, and ride shares, are also the areas where ventilation improvements can be applied to reduce the spread of virus and lower the risk of exposure. Health risks and proper ventilation. Health risks that are associated with improper ventilation are allergies, asthma, throat infection, irritation of eyes, nose, and throat, headaches, dizziness, and fatigue. What the impact of global challenges on non-communicable diseases? Two sets of pathways link the energy used to non-communicable disease, one through the air pollution and change. Now, the air pollution success mortality from ambient particulate matter exposure is attributed primarily to NCDs, ischemic heart disease, cerebrovascular disease, chronic obstructive pulmonary disease, and lung cancer with a small portion of success test, perhaps 1 in 10 due to lower respiratory infection. The next is the climate change. Climate change presents another overlapping set of pathways through the which energy use and resulting NGECs affect health and NCDs in particular. Multiple direct and indirect mechanisms operate. Now, why is ventilation important? The very that causes COVID-19 spread through very small aerosols and droplets released in exhale breath. There is evidence that in some cases these aerosols more than 2 meters in the air exhaled. This is like when the room is if the poor spend sufficient longer period If people spend sufficient longer periods of time in the room, the virus can build up in the air and people can inhale enough of it to cause infection. Now, what measures that can be taken in the home to combat COVID-19? Regular ventilation in the home is widely recognized as important to keep both people and the home healthy. Many people will find they have to balance ventilation with thermal comfort, especially in winter months when the home relies on opening windows for ventilation. For COVID-19, it's most important to ventilate, especially if someone in the home has a virus, as this can help prevent transmission to other household members. Providing additional ventilation when there are visitors in the home and just after they leave is also likely to reduce the risk in case they are infected. Now, this is the layered approach. The Center for Disease Control recommends a layered approach to reduce exposure to COVID-19. This approach includes using multiple mitigation strategies, including improvements to building ventilation to reduce the spread of disease and lower the risk of exposure. In addition to ventilation improvements, the layered approach includes physical distancing, wearing face masks, hand hygiene, and vaccination. Now, the roadmap to improve and ensure good indoor ventilation that the context of in the context of COVID-19, the finalized roadmap is divided into three settings. That is healthcare, non-residential, and residential spaces such as private houses. For each category, there is a further stratification according to the ventilation system, mechanical and natural ventilation. These are healthcare setting, residential setting, non-residential setting, and outdoor air pollution. Now there is a time for the recent update. The first article in recent updates is mitigating aerosol in infection risk in school buildings, the role of natural ventilation, volume, occupancy, and carbon dioxide monitoring. Issues linked to aerosol physics with alcohol building and related infection risk still lack a proper recognition, school safety regulations, limited spaces, and limited available window surfaces required to precisely investigate the seasonal varying factors and the occupancy volume ratios in each classroom in order to assess the specific risk level from viral loads or potentially infected resources. Moreover, most schools are still not provided with mechanical uh, heating, ventilation, and air conditioning system, nor with air quality sensors. Fundamental questions are therefore how the specific classroom volume and the specific airing cycle affect the long-range contagion risk in a given classroom. Is linear social distancing the right way to assess a volumetric risk problem? We present here the results of an extensive quantitative analysis based on GN Rayleigh infection risk model applied on a real classroom scenario. The study discusses seasonality of the airing flow and the effectiveness of a single and combined mitigation interventions such as limiting student group replication with microphones, increasing classroom volumes, educating classrooms with carbon dioxide sensor to safely drive airing intervals. Moreover, we show experimental carbon dioxide concentrations as well as occupancy and airing factors um, monitor in a real time in a real classroom scenario. In agreement with recent literature, the results emphasize the need for a dynamic evaluation of complex risk function over the whole exposure time and not just the monitoring of the instantaneous carbon dioxide concentration in order to correctly control that infection risk from aerosol. The second article is the influence of indoor thermal conditions on ventilation flow and pollution discussion in downstream industry workshop. Natural ventilation is often used in industry workshops with high intensity heat sources and pollution sources indoors because such workshops require large amounts of ventilation. In this study, a numerical simulation of the pollutant dispersion between two adjacent industrial workshops is performed with the focus of the effects of the downstream workshops, thermal conditions on the floor, and pollution dispersion. The results indicate that there is significant interaction between the wind and the buoyancy generated by the downstream workshop's heat source, and this relationship can be evaluated using the Richardson number. Firstly, the Richardson number affects the ventilation direction of the downstream workshop. When the Richardson number is less than 1.6, the airflow is mainly driven by the wind, which blows from the leeward of the downstream workshop to the street canyon. When Richardson number is greater than 1.6, the buoyancy effect begins non-negligible. The ventilation of the downstream workshop comes from the street canyon. There is the low concentration of pedestrian breathing area and downstream workshop when the airflow is driven by wind. When the airflow is driven by the buoyancy, the pollution The fruits migrate to the pedestrian breathing area and the downstream production. So the time for the MCQs. First MCQ is the a construction company XYZ wants to build multi-story small purpose build building based on economical and affordable system in which most of the use is made of doors, windows, ventilators, and skylights to make the room properly ventilated without using fancy equipment. Which of the following options is correct for the above scenario? Whether artificial ventilation, air conditioning, natural ventilation, mechanical ventilation, or the mixed mode model. It's natural ventilation. Second is in a household XYZ, the difference of temperature between the outside air and the inside air tends to the deposition of moisture in the room surfaces, which can be effectively controlled by the provision of suitable ventilation of the room. Which of the following option correctly defines this? Where the ventilation between condensation, dissipation, or precipitation? It's condensation. An owner of the company XYZ called a meeting to find out the person for a reason for so many sick leaves of the employees still that have fallen ill frequently due to respiratory tract infections. Inquiring, he came to know that an exceeded level of the component in the air above normal comfort value of that is 650 parts per meter of the outside air was the cause. Which of the following component of air is the correct option? Whether oxygen, hydrogen, carbon dioxide, carbon monoxide, or the nitrogen. The multi-story purpose building for their new hospital near the city center. They want to invest in ventilation system in which the partial vacuum is created inside the room by removing the ventilator inside the air by fans or the blow for maintaining the comfortable environment. Which of the following is the correct option for such system? Whether supply plenum, air conditioning, exhaust, or air coolers. It's the exhaust system. If I'm sitting in a restaurant XYZ, most of the employees working in the main kitchen complains of unusual quantity of heat or odor. The manager plans to upgrade the ventilation system using the mechanism that is used and that is just the reverse of the exhaust system by installing input fans in outside wall. Which of the following is the correct option? Whether air conditioning like or air cooler. It's the supply system. During the COVID-19 pandemic, after lockdown, most of the people going back to their offices were very much concerned about working in the closed space environment. Such space, several people are working. There must be dash to cause proper ventilation for the premises, whether air change, humidity, temperature, moisture, or clean air. It's air change. Seventh, Mr. Ali visits the relative house that is well constructed and well ventilated home. On inquiring, he finds that the installed ventilation system consists of an exhaust system, supply and air conditioning. By definition, all of the mentioned terms comes under which of the ventilation system, whether natural, mechanical, man-made, doors, or chemical. It's be mechanical. Our company XYZ installed latest technology gadgets in newly constructed school for controlling air with respect to humidity, temperature, movement of air, bacteria contact for providing a healthy and comfortable environment to the teachers and the students. Such a system comes under heading of which of the following, whether air conditioning, circulation, condensation, conditioning, or chemical. It's air conditioning system. Ninth MCQ is Mr. Bass plans to build new motor and well-ventilated house, keeping in mind all the system. Which of the following is by far the most effective ventilation system in a home? Whether a mechanical system that exhausts air to outside, ventilation system fan in kitchen and bathrooms only, open windows, ceiling fans with out and exhaust system, or the air conditioning system. It's a mechanical system that exhausts air to outside. Tenth MCQ is in a building to provide ultimate comfort to occupants. Which of the following is probably used nowadays? Whether air conditioning, heat, ventilation, and air conditioning, ventilation, heat, and air conditioning, open ground. It's heat, ventilation, and air conditioning system. This is the key of the MCQs. This is the YouTube link of our YouTube channel where all the presentations are uploaded. And thank you very much for today.